Um, Welcome to this session entitled Packet Analysis in the Cloud. My name is Matthew York. I work for a company called Advanced 7. We're a site reliability engineering company who basically consult on performance problems around applications, networks, various things like that. And the background around this particular presentation is that obviously a bunch of our customers are in the process of adopting a cloud-first strategy. They're kind of moving from on-premise hardware to a whatever, whether it be a hybrid cloud or a public cloud or a private cloud. And this is kind of some of the lessons we've learned along the way of how we can get packets in that environment. It's going to be a bunch about capturing packets and also a little bit about analyzing packets in the cloud as well. So that's kind of the background. So if we start just to sort of give some scope on what we're going to talk about here, if I can get my Outlook working. Okay, so clouds are big, they're getting bigger, and there's billions of them. And every single day, all of the clouds add a new service, whether it be something funky around Internet of Things, messaging, whatever. There's a whole mass of services that all the public clouds provide. So I can't cover all that today, and unless we'll be here all night. And to be honest, there's probably not that much benefit in doing that anyway. So the idea is to cover a small subset of the services, really the key ones that we see our customers using and people are using generally. And our focus is also on Amazon Web Services. Generally, we're going to be using that as the examples here, again, driven by market share, client demand. However, all the sort of things we talk about with AWS are basically pretty relevant for the other clouds as well, and maybe we'll do that at another session sometime. So, starting with, 2 years ago I went to SharkFest in Mountain View, and I think Gerald's slide, one of the slides he had in his welcoming presentation was this, that said, packet captures in the cloud is TCP dump. And that was as true then as it is now. And you know, from the start, that sounds horrendous. Okay, you know, we've come from an environment where we've had our own hardware. 20 years ago, there was no virtualization, right? We could just tap every single network interface we want. We can see the data going everywhere. We then, 10 years ago, 15 years ago, whatever, started bringing in ESX. We started losing visibility immediately there of our network. So we started doing things like promiscuous mode vSwitching, monitoring, looking at east-west traffic in virtualization platforms. And the migration to the cloud is the next stage on. You've lost that access to the hypervisor, which makes it really difficult to get packets, but not impossible. But as soon as you accept that, you know, that is completely out of your hands, then in 2018, packet capture in the cloud is TCP dump, but that's okay. We've accepted it, and we're going to try and engineer our way around that particular problem. And there's a few things that we can do around it. So, if you think about moving to the cloud, this is a picture of a very, very simple cloud-based application, right? You've got a client on the left-hand side. It's using an application load balancer, and it's got a web server in the middle, and it's got a managed database on the right-hand side, right? Three very simple components that pretty much every application is going to have. Your ALB, your first component, you don't manage, right? That's an Amazon thing. You're never gonna get visibility of that. Can't get packets there. The backend database, again, managed by Amazon. You're not going to get packets there either. Okay, but the middle is the web server, and this is your environment. This is, in this case, we're talking about an EC2 instance. You can get packets there. This is a component that you manage yourself. So this is where you're controlling. And if you think about it, that's actually all that's important, because who cares about what packets are doing from the database's perspective, because really you're buying a service of someone, and it's the response times you get from that service that's important. So the focus of all captures, from our perspective in the cloud, is on things that you have control of. And it's a business decision, right? It's a strategy decision. If you choose to move to the cloud and you choose to give all of your infrastructure into a managed service, whether it be a managed load balancer or a managed database, then you've got to know up front that there goes my visibility of it. And that needs to be thought about as part of the design stage. Obviously, in a cloud environment, you can build your own load balancers and configure them and manage them yourself. You know, after all, we're talking about instances or virtual machines, basically. So if you want to manage them and you want the packets, then that's down to you. Difficult argument to have, I appreciate that, but that's kind of where we are. So, how do you start by getting packets? Well, we're capturing here, we're going to capture on instances, so we're going to be running TCP dump, we're going to be running dump cap and things like that. We've got a whole different plethora of ways that we can do that. And the simplest way of doing that is by saving our data to block storage. Now this is where it starts becoming a little better by moving to the cloud, because if you ever go to an organization now and go, right, we want to run TCP dump, or we want to run dump cap on your application server, they go, no, haven't got the storage. And you say, well, give us some storage. Well, it's going to take you 50 days because we're going to get more spindles, we need to get, allocate stuff, whole lot of stuff. Well, this environment, brilliant, don't need to worry about that. It's point and click computing, the cloud, right? So, okay, so we want to go, so let's just start very briefly. Okay, I've got an instance and I want to allocate some more storage. Oh, sorry. Sorry. Okay, I will endeavor to speak a little bit slower. Apologies. Okay, so if we've got a sort of a private, an account on SharkFest account, funnily enough, on AWS here, based in the island region, and we've got a bunch of tools that we're going to use to demonstrate how you can do this stuff, hopefully, within this environment. So the first place we're starting here is managed instances. So self-managed instances. So we're talking about EC2, which is Elastic Compute Cloud. So if I come in here, I can see I've got 4 running instances here, and one of these instances is my web server. Okay, so we can start new instances and do a whole bunch of stuff in here. But the point of this is, right, okay, we want to allocate some additional resource to this particular web server for running TCP dump. Well, okay, so that's being backed by block storage, by Elastic Block Storage. So we can come in and we can create a volume very simply. Okay, I want 100 gigabyte partition to start saving my TCP dump data. Okay, I'm going to come in here. I'm going to say I just want it backed by SSDs, 100 gigabytes. We're going to stick it in the same region as our instance is running, all that kind of stuff. Don't worry about the other settings at the moment. We're just going to leave it for default. Okay, we're going to create that volume. So we've created a 100 gigabyte volume there. It's just spinning up. If I scroll here, you can see it's oh, hang on. If I click a refresh here, it should be added to our little table in here. Okay, so it's available, but it hasn't been allocated to it. So if I just give it a name and go dump data. I better speak slower, or that'll be over in 10 minutes as well. That won't be good. Okay, so if we, you still get the same amount of content, you just get it quickly. No, so I've got my my partition there of dump data, and I want to allocate that to our particular web server. So I come back to my instances view, look at my web server, and then I can right-click on there and go. Apologies, other way around. I can right-click on it and the dump data and go attach volume on our volume and attach it to our web server instance in here. Web server. Pick a device, in this case it's fine to use that, and we attach it, and immediately that will get attached and provisioned and made available to our web server, and at that point we can just go on using SSH and run the standard mount commands as you would and write your data into it. That's great. Nothing spectacularly exciting about that, I understand. So you've got your 100 gigs worth of data. Well, obviously the simplest thing to do, or the obvious thing to do, would be to FTP on there or SSH copy and get all that data off that drive. Obviously, again, going back to the cloud, that makes it easier. We can just, with a few clicks, we can detach our storage from our web server and then reattach it to another machine that we've got Wireshark on. So we can then start analyzing packets that way, which is great. So if I was to go back to my volumes, it's a case of detaching. I'd unmount it in the operating system as you would any other mount partition. I can detach it from one. Excuse me. Once that's detached and become available again, which it has, then obviously we can just attach it to our analyzer. We've got our data there, and we can move it around and do whatever we like at that point. So that's great. That's basic. You know, we've kind of moved the data around, but it's a lot quicker and it's a lot easier than perhaps it would have been in a legacy type environment. So this is where we've got to embrace what we can do in the cloud, and that's one of the first ways we can do it. So moving on from that, you know, that's quite a manual process. It's quite a managed process. What else could we do, and how else could we utilize stuff in the cloud? So the next option is we want to scale that a bit. Okay, so rather than attaching block storage to our individual instances, we can use another service that is available here, which is EFS, which is Elastic File Storage. So it exposes an NFS mount, and you can just mount that and capture to your heart's content away, multiple servers all going to the same thing. The way this works is that when you mount it, it appears as an 8 exabyte drive, so you can capture and as far as your wallet will take you, basically. But obviously there's a few things to consider about when you're doing this. Primarily, how you configure EFS. So EFS has out of the box, comes with two different options. It comes with burst mode or provision mode. So this is based on the amount of data that you're going to send into the EFS partition. And lifecycle management, right? If you're going to keep writing 8 exabytes worth of data, then you're going to need to manage that and probably expire it after a while. Otherwise, it's just going to become crazy. But you've got to do that manually. And then and the third option is the bandwidth you've got available. So depending on what sort of instance type your application is deployed on, you'll get a certain amount of bandwidth. And that's all in the tables on the website. You can look up this one will have 100 megabits per second or whatever, up to 40 gigs. And you can kind of figure it out. So you just need to manage that kind of expectation. But it's really good. So if I was to have a look in the Amazon console and look at EFS, it's as you would expect, it's a point and click type thing. You can have, you know, your storage, your NFS partitions up and running within a few minutes. So this is an EFS drive that we've created previously, that I created previously for this, that is actually running in burst mode. So that's going to give me a certain amount of throughput. I happen to then discover that actually I need more throughput than that, and I want to provision it because because actually the data rates that I'm writing to this are higher than I thought. So again, it's a case of coming in and going, actually, no, I want 100 megabytes per second or whatever it might be, and it gives you the cost of the prices are there. But, you know, so we came unstuck on one of these problems. We kind of built a system with burst mode enabled. We were writing data at it for a period. We were capturing data at it, and suddenly it started performing really badly, and we couldn't figure out why. And it turned out that basically what Amazon were doing in burst mode is that you can burst up to a set amount, and then your bandwidth starts getting throttled until you come back down that allowance, below that allowance. So how do you check that? So the AWS CloudWatch service is basically centralized logging, monitoring for everything you can imagine. So if you've got an EFS partition, then metrics for that will be stored in this metrics section. Again, so if I pick up and just drill into EFS there, then we can see we've got two different file systems metrics here. We've got permitted throughput over time and the burst credit balance over time, right? You're using a certain amount of burst credits when you peak above your normal permitted throughput, which the permitted throughput in this case is 105 by default. As you can see, we're not really writing anything to it, so it's not that important for the purpose of this, or the fact that everything's flatline, should I say. So that's kind of EFS, and that's one option, and that's great, and you can configure loads of machines to write data across to it. But then what happens? So at that point, your ops people start moaning at you and saying, your captures are killing me. This is not, you know, you're using up too much CPU, too much disk space, whatever it might be. And you kind of then you get into an argument about saying, no, you don't, you do, you don't, let's prove it, or whatever. But that kind of argument misses the whole point of the cloud in a way, and I'll explain why in a second. Because, you know, if that is the case, then you just change the instance type, right? you just allocate, if you really think that's the case, then you can just allocate more instance type against it. We find most people's reticence is not around, it's just a default reaction to say, no, you can't run it. You can't run stuff on my application service. And this is where it's a thought process where it comes back to the conversations you have with people and go, okay, you need to, rather than we're thinking about machines having physical memory and number of CPU cycles, then sort of change that into a commodity type resource where, it's just CPU and it's just RAM, then it doesn't matter what you're using it for. You just need to scale your system and size it correctly. As it goes back to this point of monitoring and support is a strategy. It's not something you retrospectively have to or want to add into your application platforms. It's something you want to do up front. So that's the simplest option, is get a bigger instance. Nice and easy. Again, even if we wanted to do that, that's a point and click thing, really. You shut down an instance. If I click the right button, that is, go back, looking back at our instances, I can shut down an instance. I can change the instance type. This instance isn't running, so I can't do it at the moment. But bang, give it more CPU. All those kind of simple things you might think make life really easy in this environment. The second option, your application, people say your captures are killing me. Well, they should be using auto-scaling groups. This is the whole point of the cloud. If you're deploying applications and you're provisioning all the resource you might expect at the busiest time of your life, then you're doing it wrong. The whole point of this is that you build scaling groups that will change before that will scale up and down depending on demand of your application at that time. In the middle of the night, you may have nobody using it. In the middle of the night, you may have loads of things happening because you run a bunch of batch processes after the end of day, whatever it might be. But the point is that, again, you're treating it like CPU, you're treating it like memory, you're treating it like it's just another commodity you're using. And when you think about it like that, running captures, great, it doesn't matter because your argument can't be your captures are killing us because we can just scale up. Yes, there might be a small argument around kernel time and things like that, but you've got to get some real good evidence to prove that your captures are causing problems. So that's our view. We always say, no, we've got to capture. So people will still say their captures are killing me. People still capture to me. You can't capture on my device. Where else can you capture? And to sort of get a quick understanding of this, you have to understand a little bit about how VPC networking works in the cloud environment. So, and this is there's an AWS reInvent conference video on YouTube that I'd recommend everyone watching called Another Day, Another Billion Packets, which talks in depth about how AWS VPC works, but at a very broad, sort of high-level thing. To understand why it's not so easy just to use a capture device, you've got to understand that what AWS does and other clouds do is basically it's hijack layer 2 and make everything point-to-point between each host. So where you think, and this is where it comes, is this concept of a mapping service. So where you would imagine in a traditional Ethernet network, your instance, your VM, your operating system, whatever it might be, would send out an ARP request for whether it be a routing address in your routing table or another machine you want to send an IP packet to. That would hit the Ethernet switch and you'd get a proper response. That doesn't happen in VPC. What happens is that you send that, and a mapping service, which is running on every single host in every single data center, hijacks that ARP request and just looks it up, sees whether you've got permissions to send to that particular endpoint, whether you've got permissions to, whether that endpoint sits in your VPC, and then basically gives you a made-up MAC address and sends it back to you and says, yeah, there you go, send it across this packet. Otherwise, it flags an alert to AWS support and says you're trying to do something that you shouldn't be able to do. So at that point, you get your ARP request back, and you then want to send your IP packet to the other end. So in this example, we've got 10.0.0.2 in blue trying to send a packet to 10.0.0.3. And what Amazon does, it encapsulates that packet in this kind of headery thing we got down here. At the bottom, it gives it a VPC tag saying this is the blue VPC. It gives it the source destination of the actual host that your machine is running on, and the destination of the host that the other end is running on. And that's how it gets sent across the network. And then when it hits the other end, obviously the IP destination at the other end is the host. It talks to the mapping service, checks that this packet's come from the right place, and unwraps and encapsulates it, and then sends it on to you. So if you can sort of see how that kind of works, what it means is that you can't then start using routing tables to route through devices. You can't say, we're going to send, I'm going to build another instance that I'm going to configure IP tables or something like that on it and use that to do capturing and forward packets from end to end. You can't do that because it's end to end at layer 3. So that makes that really quite annoying. So really your only choice you've got in this environment is to do some natting somewhere. And there you're starting to break. You're changing the configuration of your application at that point. Because obviously if you're doing natting, then you can build some kind of NAT device with that IP tables or whatever it is that's doing the forwarding and the capturing and stick that between your web server and your application server and get around it that way. But you're adding another active component in the middle of your data flows, your application, which causes some other problems. So we've got that far. That's, and the argument still goes back to you just want to capture on your servers, but you've got to do it in a better way. So if we kind of leave the natting concept for a minute, because I'm sure that's reasonably self-explanatory, we're going to kind of move on to the next kind of piece, which is around containers. Now, you may or may not be hugely familiar with containers, but if again going back to a cloud, the cloud probably model that people would typically take is the first thing they'll do. They'd lift and shift their current applications and stick them into EC2 and manage those instances, go on. They'd have their app people or their ops people configuring servers and stuff like that. The logical next step to that, especially, and it's not just logical, it's essential if you really want to scale to any big size, is to containerize your applications. So this is the concept where, containers being a package of complete resources, the software, the configuration, everything that your application might need, and put in a standalone unit. And then if you've got that, you can think about running loads of those across a cluster of hardware along the bottom or a cluster of instances along the bottom, and it doesn't matter where they are. They've got the amount of resources they need. They've got everything they need to run it. It's all scripted. It's all coded. You don't have to think about anything. So, and a lot of the other services that we'll only touch on lightly around things like functions as a service, Lambda functions, perhaps messaging in various different levels. If you were to think about, if you were running big MapReduce jobs on AWS, that all that stuff is running in containers. And Amazon is managing those containers for you, but all that stuff is running in containers, and that's basically the easiest way to do it. So if we think, okay, so that's where we're going to go with this, and this is what we do internally for our stuff, we're tiny. It's great. It makes life so much easier. Then conceptually, when you think about containers, then there's a new service we're talking about here, which is ECS, which is the Elastic Container Service, that Amazon manages for you. It's a container orchestration and management service. Others are available, like Kubernetes, you may have heard of, which is a Google-backed project. But essentially the same point. They all have the same point. You've got a bunch of containers. You want to schedule them to run stuff across your estate of instances, and this helps you do it. So if I use the word service there, you've got if you think I've got my service, which is web servers, then I've got a service called web servers that is made up of tasks, and each task is a particular instance of a running web server. So you've got a pool which would equate to your service, and then you've got a task, and that's a little important thing to remember there. So and again, the final piece along the bottom is that all this stuff on the containers and things like that live in a container registry, and that sort of holds the bulk of your data, and you pull those when you launch new tasks. They get pulled in from there. So if I think about so we've got a very simple application here, and it's in ECS, and I thought I'd just quickly go into there and show you what that's all about. So I've got an ECS cluster called SharkFest 18 Europe. It's currently got one container instance running in it. You'd expect to have a lot more than one, but because it's pay-as-you-go, it's one. And I've got one service running on there at the moment. And so if I have a look at that, I've got a service which is called hello. And hello, if I go back to my, if I just pick up the DNS name for my service, is just a web server that will respond back to me saying hello, hello, hello world. So I've got a little script that will poll that, that just does that. It's got to be dark in here, that's why. And we'll just start that running, and that will start generating some traffic that's going to hit that web server by sending a request into it every 10 seconds. So that's good. So we'll leave that. So we've got our initial cluster, and if we just have a quick look at how that might look on the cluster environment. So if I can SSH to the particular server that's running on our instance, and what I can have a look in here is I can have a look at I can just see the running Docker containers I've got. I've got 2 running Docker containers in here. The ECS agent, which is the bit managed by Amazon at the bottom, and I've got our Hello World Nginx web server as well. Nothing clever about that. So then what I can start doing is, okay, I can start, if I've got Wireshark on here, I've got dumpcap on here, then I can have a look and do a dumpcap -d, and have a look at the interfaces that we've got on this particular machine. What happens here, we've got ETH1, standard normal stuff. We've got a second virtual adapter, which is Docker 0, which you'll get one of on all of your hosts. Now, this is a Docker network that if you have multiple containers that are running on the same instance talking to each other, sorry, I'll start slowing down again. If you've got multiple instances, multiple containers talking to each other, then they'll be talking across this Docker 1 virtual network. Think of it like a virtual switch, I guess. And then we've got a bunch of other standard Linux type stuff. And then we've got interface number 5 down the bottom here, which is virtual Ethernet address. And this is the virtual adapter that is being created for our Docker container that is running at the top. That's great. So from this point, we can then start doing that. We can start having a look at. We can do a tshark minus interface, and then look at 5, and we should start seeing, with any luck, depending on how the 10 seconds happens, we will start seeing our traffic hitting this particular server for my polling. With any luck, there you go. There's my HTTP request coming in and out. So that's great. So that means that we can SSH on, we can TCP dump or dumpcap, tshark, or whatever it might be, the particular interfaces that on Docker containers that we're interested in. Now, that's kind of great, but that can be quite cumbersome, because if you think you've got thousands of Docker containers, we don't want to do it like that. We want to do it a different way. Just as a quick note on this, one of the things we have got is that you'll notice that the source address here, which is of these packets, is 213.1 whatever, is the Hilton, the Marriott, whatever we're in here, and the address on the outside is 172.17.0.2 that it's going to. If I have a look at the IP address of the instance that I'm on, you can see we've got our actually the instance of this is the instance IP address is 10.0.0.232. However, that Docker network that I was talking about earlier is the one that's sitting on 172.17.0.1. So you can see that the packets have been destination natted by the time that you see them on that virtual adapter. And that's something to bear in mind when we get to something a bit later on. So if you wanted to, you could just verify that. Oh, the virtual adapter down the bottom here doesn't actually have an IP address associated against it. So what we could do is we could actually just run the run the IP address in our Docker container and for IP ADDR, and then we can see that's, oh, there we go, that's where that 172.17.0.2 address has come from. So we can have a look at that. So really what we don't want to do is we want to have a way of capturing across multiple containers at the same time from the host. Now, and the way we approach that is by using, if I can go back to my PowerPoint, is by using another Docker container that we're going to call TCP dump. You can call it dumpcap, you can put whatever you want in it, it doesn't matter. You get the idea. Excuse me. Now, what we can do with that is that we can configure this to run and capture data on the interface 1, or the interface any, more particularly, which will then give us all the data for all of our stuff coming into from the outside, the NAT stuff in between, and also any of the cross east-west Docker traffic as well, which is great. So how do we do that? What's the easiest way to do that? Well, we can have a look at that now. So we've got in source control, because we source controlled it, and in code commit, we have got, and this is where it's a Docker container is built in a Docker file. It's just a standard text file, and it's 4 lines of code in here. This is how we can create our capture container. We've got it coming in, and a Docker container basically starts from a build on something else. So what we're saying is here we're going from Alpine being like a 16 megabyte Linux distribution. We're going to expose a particular volume called data, and then we're going to install TCP dump and a bunch of other stuff, and then we're going to run TCP dump with some parameters. So we've got that kind of container. That's how we would configure the container. We'd build that container, which we have done, and we would then push that into our repository. So if we have a look at our repositories in here, we have a repository called capture, and this is when we built it 2 days ago, then that's where our container is sitting. So now we've kind of got our container built. We now need to deploy that across our cluster of instances. And to do that, we define a task. If you remember, we went back to, we've got services. Services are made up of tasks. And to get a task, we've got to get a task definition. So we have a task definition. We've got 3 in here. Hello is one of the, was our web server. We'll come back to filter in a bit. And we've got capture. So if I have a look at this capture 4, I've got 4 versions of it. I'll create a new version just because it looks easier on the screen for here. So what have we done in here? So we're creating a task, we're calling it capture. We're giving it a network mode host. Now this is important because normally when you're deploying services on a ECS cluster or any container cluster, you would by default give it a bridge network or an native network. But because we're trying to do something special here, we want access to the host network. So by selecting host in here, this capture container will have the stack of the core operating system, which means we can then do that -i any, and we can see all the stuff that's coming in and coming out. So there's a bunch of other sort of parameters in here. I haven't gone into much detail about these at the moment, but we can restrict things around the memory and the CPU. Now, this is exciting because the concept of restricting the CPU and the memory makes it even better for your application people who are moaning at you about running stuff on their servers, because this takes care of it. That answers that question definitively, because I'm only going to use this many cycles. Your application container is going to use this many cycles. There's no argument about it, which is great. So we like that. So we define it, we give it some memory in there, and this is where we would then define our parameters in here. So we've got a parameters of -i any. We've got just some standard stuff. We're slicing at 256. We're using a G because I want to roll these over every minute, and we're going to exclude. We're going to filter out our NFS traffic because we're writing this stuff out to NFS. We don't want to get in an ever-continuing circle of stuff getting captured. So because we don't want to capture what we're doing. So, and then we're writing it out to a file name. So we're not, at this point, we're not actually sticking in a ring buffer. So we're not going to write out, we're not going to start deleting data after time. So we've got to think about how we're going to manage the lifecycle data a bit later on, and I'll come to that. So we got logging, we're exposing a mount. So in this particular case, we've actually mounted the NFS share at the operating system level rather than the container level, just to make life easier. We could mount it at the operating system, in the container level, but because we've done it that way, we just need to pass it through as a mount point, which is what we've done here to be /data, configured logging and stuff like that. So that's kind of, we can create our task definition there. That's ACE. Now we need to build our service into our cluster, and that becomes really easy. So again, we go back to our cluster, and we want to, on our services tab, we're going to click create, as you would expect. Now, we're going to launch an EC2 type, because that's what our cluster is. We're picking our task definition, which is capture, the revision of 4, cluster name, and we're going to give this a service name of capture. Now, we want, it's going to ask us how many tasks we want to deploy. So we're going to say, I want to deploy 100 tasks. So theoretically, when we click OK, it's going to try and deploy 100 instances of this capture, which could cause us problems or will cause us problems in this environment. But it may be we want to cater to the fact of, okay, in our instance in a few weeks' time, we might start adding more instances to the cluster as our application teams start growing things. Or we have an auto-scaling group in place that creates more instances as load goes up and down, and we don't want to miss any data. So we're going to set that as 100, and then we're going to use something that's called a placement template and go, we want 1 task per host. So that's going to say is that you can, which actually makes the number of tasks irrelevant. You could set it to a billion if you like, and it's only ever going to stick 1 task for every instance you've got. But that's good. That's what we want, because it means we're going to get complete coverage of network traffic coming into and out of our instances. So if I go to the next stage, it's going to ask me things around how I want to access this by load balancer. Now, because we're not serving front-end traffic, we don't care about this, right? We'll just leave it as none. It doesn't matter. We're not going to map any ports or anything like that. This is just a thing that's going to run on all the machines. And again, auto-scaling, don't need to worry about that. And then I'm going to create my service. That is our service created. So at this point, we can see, have a look at our capture service. We've got a desired count of 100, no running count of 0. And hopefully with a bit of luck, bang, we've got a running count of 1. TCP dump has been deployed to our instance. And if we were to have a look at the logs for that, because we're basically capturing standard out and standard error, then we can see the standard message you would get out of TCP dump when you launch it. So that's cool. So, and if we were to go back and have a look on our host, then as you would expect to see, you can see our new capture instance there is there doing things, and TCP dump is running nicely. That's great. That's made it really easy for us to deploy TCP dump across our estate. So that's good, but if you remember, there was a few other considerations that are that make this really difficult. So things like the lifecycle management, all that kind of stuff. So we've got another solution for that. So we can scale this even more. So where previously we were writing stuff out to EFS, we're now not going to write stuff to EFS, because we're going to write it out to another storage service, which is AWS3, which you may or may not have heard of, because that gives us a whole bunch of other stuff that we can do with it that can overcome some of our other problems. Now, S3 is object storage. You're chucking a file at it, whatever it might be, and you're reading that file back. So that's what we're going to use. But to do that, S3 normally exposes a web services interface that you normally write stuff into and out of it with a RESTful API that you might use in your whatever application it might be that you might use. So we need to essentially front NFS with that. So, and the way we do that is we use another AWS service called Storage Gateway. Now, Storage Gateway originally, you can actually buy it as a hardware appliance. You can buy it as an ESX VM or an Oracle VBox, whatever, and deploy it in your data center and allow you to back storage back to S3, which is highly durable, highly scalable, whatever. So, but you can also do it as we've done it here. We've deployed Storage Gateway as an instance into our EC2 environment. So if you remember, you probably saw it earlier on, then we've got a fourth instance here, which is a Storage Gateway. So that's up and running. That's basically semi-managed. In fact, it is semi-managed. You can launch multiples of them if you want, depending on what your need is. And then we can manage that through, and sorry, the way the Storage Gateway works, I should have said that, is that it exposes, as I said, an NFS, or in this case now an SMB, so you can back your Windows stuff to it as well, mount points or shares, whichever way you want to look at it, and then it runs a cache on that particular instance. So, so you write to it, you can read out of it, whatever, and then it will background persist that into S3. Now, in this particular use case, we don't care about reading, so we don't actually care really that much about the read cache performance. All we care about is writing to it. And so really, you allocate storage to a storage gateway based on your expectations for how long things might live in the cache, because that's the fastest way it's going to respond when you're trying to read stuff back. But we don't care about that. So your cache size only needs to be as big as storage gateway can write stuff into S3. So that's kind of that makes that a little bit easier to size and to scale, because you can have a look and you can figure that one out as when you're looking at when things are popping through either side. So that's storage gateway, and again, you know, it's point and click computing, which makes, you know, life easier. So we got storage gateway in here, and we have essentially got a file share that is backed by an S3 bucket. We're saying everything that you write to this storage gateway over NFS is going to be chucked into this bucket. So if I have a look at this bucket, I cheated slightly earlier on, where when I actually deployed our capture device, the NFS mount share wasn't actually to EFS, it was to storage gateway. So hopefully, if I was to have a look at our capture device now, if I was to look at our S3 bucket now, we've got a couple of folders in here, and with any luck, we've got some TCP dump. Because I started this 4 minutes ago, we've got four minutes worth of TCP dump files that are immediately backed into S3, which is great. So, and obviously, you know, we can, as you would expect, we can download those, and we can, you know, as you would expect, open them in Wireshark and do whatever you like with them. Nothing clever there particularly. So, what happens next? As I alluded to on this particular picture, we've got this thing on the right-hand side called AWS Glacier. Now, Glacier is basically, probably, he says, magnetic back storage option from AWS. If you think about how you would access something in S3 or any particular storage, you would try and read something and it would give you that data straight away. Well, Glacier doesn't quite work like that. It says, I want to read this data, and Amazon come back and tell you, okay, it's going to take us like 6 hours worth of to get you that data. But the trade-off with that is that it's incredibly cheap to then store stuff in Glacier, which is great. And all this, you can see where this is all going. This is all going to the fact that all the limits you had on your capture devices when there were physical devices in your on-premise data centers has gone away. You can capture, as like I said earlier, as much as your budget will let you. Now, okay, how do we set that up and how do we work it? So if I have a look at my bucket level, I can have a look at the management tab in here, and I can look at the lifecycle. So what I can say is I can create a lifecycle rule that's going to be, so we're going to call this archiving. So we're going to say we're going to archive here, and we're going to add a transition that says after 30 days we're going to start it. I'm going to need to pick a transaction type. So by default, this bucket has been set up to be to replicate across an entire region being made up of multiple availability zones, right? So, but this, which gives you maximum durability, maximum retention and performance. But after 30 days, I can start losing a bit of latency. I may even start it straight away with this kind of data, right? But all I can say is after 30 days, stop replicating it across all your availability zones, just put it in one, and I'll be happy with that. And then we can say, after 60 days, stick it in Glacier, stick it in the cheapest kind of data I've got. That's great. It's going to move that data. It's going to make it cheaper for me to run. And then, depending on your expectations or your demands, rather, then you can then change. You can then start deleting things out of your bucket after a set period of time. So at this point, because we're copying our data there, we're going to say, I don't know where 425s come from, but after a year, because that's what I care about, my packet data is going to disappear. And you know, this is great, right? So you've kind of handled that lifecycle management out of it away to someone else, and it's all automated, and you don't have to worry about it. So that's really cool. So that's good. So we can do that, and we can create those rules and do that. So that's kind of got capture sorted, sort of, in a way, as much as we can at a very kind of limited level. So we've got it coming into there. Now, then we start thinking about, okay, what can we do, and how can we utilize the cloud to help us on the analysis side of things? Well, this is where this model comes in really well here as well. So if I jump back to here and just checking I haven't, there you go, it is the right place. So one of the great functions of S3 and this kind of thing is that it'll allow you to set fire alerts and fire activities on the basis of events. So in this particular event, what we do, or what we're interested in is, okay, for whatever reason, I really like SYN packets. And that's the example that I'm going to use here, is that I've got full packet data coming in, but I'm really kind of only interested in this SYN packet. How can I get those SYN packets? Well, obviously I could go into S3, I could download them, and then I could filter out those packets as you'd expect. But I've got 1,000 instances writing billions of packets a second. How can I do that slightly better? And this is where alerts come in. So we've got our S3, and we will, at this point, we're going to configure an alert to another service in the middle there. We're all about the services here, called SQS. And SQS stands for Simple Queue Service. And if you're kind of familiar with enterprise message buses and stuff like that, this is basically what that is. The concept of you're sending a message to a service, and any subscribers to that particular service, slightly different here, will work on that. So that's what we're going to do, and then we're going to, on the right-hand side, we're going to build some stuff, and we're going to analyze it. We're going to filter those packets, and we're going to chuck them back into S3 at the end. So we've got filtered data. So let's look at how we could do that. So if I just get rid of my reminder there. Okay, so first things first, we need to create our SQS queue. So this is again another service. So if I look it up in here in our service manual, this is the simplest way you could set anything up in the world. I'm going to create a new queue. My queue is going to be called my queue2. My queue2, start badly, doesn't really matter. And then I can create my queue. That's my queue. I can go on there and add the right permissions. There's a queue I created earlier that I'm going to be using for this, which is the new capture files, and we've got a bunch of permissions and restrictions around this that actually the only people that can send messages to this queue is my S3 bucket. So we've got some great, all of this stuff, there's really fine-grained security we can put around the whole thing. Now, as you can see, we've got messages available currently in this queue for new capture files of 10, which means that my S3 bucket has been sending 10 files into 10 messages in there. That's how many TCP dumps. It was 10 minutes ago I started it. So how do I do that? So back to our S3 bucket. If we have a look at the properties in there, then we can scroll down and we have this option in here called events. Now in events, we have this event that I created. But if I have a look at the edit of it, you can see exactly how simple this is that we're going to call this event new capture file on, it's going to fire on object create. We're only interested in stuff with the prefix of source /, so that's everything in my source folder because that's where TCP dump was configured to send stuff. And it's going to send us this SQS queue on the output using new capture files. So that's good. If we have a look at our messages, we can actually have from internally here, we can have a look at we can actually view these messages. So if I was to have a look at view/delete messages, I'll have a quick poll of the messages. We can have a look at them, and basically the messages is going to be a JSON message with a bunch of other stuff, and also the most important thing here is the key to our TCP dump to the file that was updated at this message. So we've kind of got the alerts going into the system. Now, how do we process those alerts? Well, this is where we go back to, this is where, we can script this, right? We want to script as much as we can. So if I jump back to, I'm going to go back into code commit because that's where it is. And if you remember, I've got another repository in here called filter, unsurprisingly. And I've got a Python file in here that does a bunch of importing stuff. We'll stick this on our GitHub account or something, so if you want to have a look and butcher it, then please do. But essentially what that does is that takes in a bunch of parameters that we're going to give it in a minute through our ECS task definition, and around the bucket names, around the queue names and stuff like that. And there are basic 3 very simple stages in here. It's going to get the file from S3, which is what it's doing here by downloading the file, download file, rather unsurprisingly. We're going to run T-Shark against it to do something, and then put it out, and then we're going to upload the output file into S3, but put it into a different area of our S3 bucket, and then we're going to delete it and all that kind of stuff. So that's our very simple Python file that's going to be doing it. You can imagine what you can do here. The limit is your mind. And then we've got a very, very simple Docker file again that basically does the same stuff. This time we're building off a CentOS just because we are. And it's installing Wireshark and doing all those kind of stuff, and then launching our analyze Python file, which is groovy. So we need to deploy that again, as we did do before, onto ECS. Let's go back to ECS. And we've got a task definition here called filter. And it's got filter through. If we have a quick look in here, it's got all the stuff that you'd expect to imagine about it. Interestingly here, we're just using the default networking mode because we don't care about all that other stuff. Because we don't need to see the host as we did previously. And we've got our Docker container, our container name, as you'd expect. Here we're giving it a bit more memory because we want to. We're giving it 512. And there's our parameters that we want to give it, because so we can reuse that same container multiple times. We may want to filter for, I don't know, DNS or something else, whatever we're interested in. And so we're passing it a filter of TCP flags then. It's a display filter, and that's what we're doing here. So, and then we give it the queue names, etc. So what we can do here, so if we just go and deploy that onto our cluster, go back to our cluster, and we can create one of those. We're going to go for EC2. We're going to call it filter. We're going to call it filter, obviously. And we're going to just have one task here. Now this is where I'll come back to it in a minute, actually, but it comes slightly interesting about auto-scaling because we can talk about that a little bit more. But there we go. So we've got number of one tasks. We'll create that. That will then get built and deployed, hopefully, in a second. We'll just wait for that. We've got a pending count. That's good. It's still starting up, which will take a little bit of time. Still pending. I could probably have a look on this side of it and have a look, see if it's there yet. Yeah, it's there. It's been created 4 seconds ago. There you go. I was a bit impatient running. And then if I have a look in my logs, with any luck, I can see it because our logging put a whole load of verbose stuff saying I'm getting the file, I'm getting the file, I'm getting the file. Go back to SQS, and as you'd imagine, if I refresh that, we should have no messages available in the queue. Perfect. And then we go back into our S3. With any luck, we should have some packets that have been beautifully filtered for us. And there we have in our sins packet, we've got our TCP dump files filtered beautifully with just sins, and all a sins packet in there. So that's quite good. That's quite useful. That's quite, upfront stuff. You can do it in advance. Now, this is where one of the things you see a lot is people talking about how you deal with massive amount of data. Now, this sets us up brilliantly for it because we're kind of pre-processing stuff in advance. It may be that we've got so much data coming in, our T-Shark commands are taking a long time in our container. So, because of the fact that we've decoupled capture from analysis and the way that we're using a central queuing system, means that then if for any reason we wanted to, we can just increase the number of filtering tasks. I'm going to increase it to 2. It may moan at me because I haven't got enough storage, but it doesn't matter. Not storage, I haven't got enough CPU. But the point is, I can scale that to 10,000 if I wanted, and I could process it. If that's how many I needed to process the data rate coming in, that's how many I can do. And that's how quick and easy it is to parallelize processing and analyzing of data if you're kind of using and really taking advantage of the cloud-type model. So hopefully, it may or may not, because I can't remember how big my Amazon instance is. It can't actually go to 2, but it doesn't matter. You get the point, right? So that's quite a nice little thing we've sort of set up there, I feel, because we've got a pretty scalable capture and analysis. Okay, analysis is the fact of, I need to know a little bit about what I'm looking for beforehand, but it may be that you are truly interested in DNS, and that's where you always start your investigation, so you can do it. You can get that data, and you can get it really quickly. So that's nice. I like that anyway. It's useful for us, and it's useful for people we do it for. So we've kind of got our data. We've analyzed it. Now, what else is there? Well, this is kind of my last point, and basically, it's not you, it's me, as this one's entitled. And with the cloud-first strategy and how you capture packets in the cloud, if you can take one thing away from today, the most important thing is if you're moving to software as a service, you need to capture on your boundary. So the most important place to capture on a cloud, if you're using cloud software, whether that be something, workforce management, email, chat, whatever, is you need to do it from the boundary, your demarcation point to wherever it might be, the internet, if you've got a VPN or an MPLS, whatever, to any of your providers. That's the most important thing, because, and this is, it's so easy as a vendor, as a software as a service vendor, to hide behind the internet, basically. Everyone's expectations of performance out of an application is restricted by their limit of how fast they think their internet is, or how fast they think their corporate network is, and that's how they set their objectives and uptime based on what you think how bad the internet is. So. And that's not great, but so the most important place that you can ever monitor is on the edge of your boundary when you're using this kind of stuff, whether it be using Profiler Gateway or whatever. And if you can't get packet capture to give you transactional level basis on your demarcation points, then put response times in your proxy logs or something as a bare minimum, because it's the best protection you ever have out of performance from software as a service vendors, because they will always say it's not them. And so what's next? Where do we take this next? Well, as I sort of started at the beginning, I'm not covering everything here. There's so much stuff that we can't cover. So we've got to fill in the gaps. There are places we don't have visibility of. So if we think about moving on to functions, so looking at Lambda, for example, where you're running things in a highly managed environment, highly restrictively sandboxed environment, it's very hard to get captures in there. So one of that previous model that we used around analyzing data using SQS and Docker containers is great, but you've got to have your Docker container up and running. It would be nice to shift that processing into a Lambda function. Lambda function being fired just when you need it, doesn't cost you any money or anything like that, or any resource or provisioning beforehand, which is great, which is what you want to do. But Lambda is a massively highly restricted environment. So it's in this case, it's a Linux container that's going to run, but everything you need to bundle to run in there needs to be contained in your deployment package. So in this example, I wanted to show you TCP dump T-Shark in a Lambda function because that would then save the whole SQS stuff. I would have lost 10 minutes of material, but it would be slightly cleaner, because that would be a nice place to go. To do that, and this is what we're trying to work out and figure out next. If anyone can help, that'd be amazing. But we've got to basically, you've got to locally link a compilation of T-Shark, because you can't rely on any other binaries being available from elsewhere. So we've got to package that up and stick it into a Lambda function and do that. And if you think about what happens after that, is that then you can if you've got this kind of base of T-Shark or dumpcap, whatever it might be, in a Lambda function, in locally linked like that, then you can start thinking about putting it into wrapping it around other functions that your users might have, again, giving you extra packet level visibility that you perhaps wouldn't have had otherwise. We do this. We've got, it may be you may have your own libraries to process data, whether they be in Python using native Python. We've got a Java library that reads PCAP files, and we expose that into Lambda functions like this. So it just makes, because we do other funky stuff, but that's what you can do, and that's how you can do it, and that's the future, I guess. Now, I'm sorry I talked so quickly. That's clearly a bad habit of mine, but has anyone got any questions? I feel like there was a lot of information there. There may have not been, but has anyone got any questions on any of that? And I will try to answer, but this is all new anyway. Yes?
Sorry if I missed it, but you don't need any promiscuous mode within containers to get all the traffic?
No, because you're setting the network mode as host, that's essentially the same thing. You get availability to all the adapters in there, so you don't need to set it. Yeah. Yes.
So when you're provisioning, can you limit by dollar amount too? Do you know if that's available?
I'm not clear on that actually. Whether you can limit by dollar amount.
Capacity driven, you can use as much as you want.
Yeah.
And you get the bill for it.
Sure.
So one of the limiting factors throughput and the peak and burst. Do you know if there's a dollar?
There is certainly a quite comprehensive alerting mechanism around billing and restrictions around billing and things like that you can do. Not tied to, it's quite decoupled from, and you can do things like, so obviously that's we're sort of using on-demand stuff here. You can then link it to, you can provision stuff in reserved instances, as it's called, and commit to like a 3-year thing and get a massively reduced price. Not at the host level, no. Yeah, sure.
Microsoft introduced the Azure Virtual Network tab some weeks ago. Do you have any experience with this?
I don't know. That's not my area, I'm afraid. I mean, that would be the nicest thing, right? It would make a lot of this redundant, but if the cloud providers did start offering packets as a service, then that's going to be the utopia, right?
The Azure service provides a virtual tab.
Okay. So, not wanting to give away the cloud provider particularly, but we've only ever had one instance. We asked them constantly to give us packet captures from the network. And the only time they ever gave it was because of this. They gave it on their end to show that the problem was in our environment or our customer's environment. And that's basically when at the moment, you'll get them at that kind of level, because it's not about me, it's you. Any other questions from anyone? Great. Thanks very much, everyone.